Okay, so now we're going to look at two more examples of function composition. We're not going too crazy deep into this today, but we are doing some, and we're just trying to expose you to this. Okay, so we're going to start with this one where we say r of p of x, right? So remember, you're always working backwards, so we always start with p of x. Okay, so let's figure out what p of x is, right? And basically, all we're doing in this first step with general function composition is just stating the obvious, which is what we know. And we know that p of x is x squared plus 2. Okay, it's x squared plus 2. All I am doing is copying this down. That's what you do in that first step. Copy that down. Okay, now for the next step, we have r of x, all right, equals x minus 6. And so now what we want to do, because we're putting this in to the function for x, is we have to replace this with this whole thing, right? That's what we discussed in the last thing. So now our new function, so this would be r of p of x, right? If I'm going to write it correctly, r of p of x is equal to, well, we take this x squared plus 2, and this is replacing this, right? So this becomes this, right? We're just replacing x with that x squared plus 2, and then finish writing your function, and then minus 6. So you write this function the same way it is, just wherever you have an x, basically put a set of parentheses for whatever your input function is, okay? And then your output is you just got to finish this thing. So you got x squared plus 2, so you can drop the parentheses. We're not multiplying or doing anything. We're minus 6, and then we can combine some like terms. We got negative 2 and negative 6. So we get our finished function is x squared minus 4. Right, and that is what r of p of x is, or r of p of x, right? So both the same thing, right? That's what we got. So that's the general idea here, right? Is just figure out which one you're plugging in, and then the one that's getting plugged into, replace the x's with the thing you're plugging into it, okay? So let's start with our r of x is the thing that we're going to substitute in. So we write that down just so we have it. R of x is equal to x minus 6. So we're going to take x minus 6, and wherever we see x in p of x, we're going to replace that, right? So regular p of x is x squared plus 2. So p of r of x means that wherever you see x, which is right here, we are going to replace it with this. So this becomes, so put a parentheses, and because this has an exponent on it, we have to include that right there. So this should, before you plug anything into it, should look like this, except that your x is gone. That's it. It should look exactly like this, except your x is gone. And now we are replacing it with this. So we're going to take that and we're going to plug that in there. So we're going to go x minus 6. And so then this becomes like, how well do you remember how to bust these things open, right? So we have x minus 6 squared. So let's, for simplicity purposes, write this out so we can multiply it, right? So it's this, right? So we go x times x is x squared. X times negative 6 is negative 6x. Now we're going to do this one right here. Negative 6 times x is negative 6x. And negative 6 times negative 6 is positive 36. And then plus 2. All right, so I'm just blowing this up, and then we're going to combine some like terms. So we're going to have x squared, and then we got minus 12x from these two. And then 36 and 2 make 38. And then you don't have to worry about factoring or anything. We have our composed function, and we're in good shape. Okay, so slightly harder looking, little more complicated than what we were doing yesterday, but it's the same idea, it's the same concept, and then we're just kind of pulling in what we know about multiplying, adding and subtracting polynomials, right? And to make these function compositions. So the big thing is just get yourself some practice at these and actually do the work on the practice sheet, and I think you'll find that they're very doable. So good luck with these guys.